Hi everybody. I'd like to welcome you to my session. I moved from .NET to GOlang, sometimes 8 months ago. And during my journey, I experienced several gotchas and aha moments. I made several mistakes, and I would like to share with you a few of them, especially a few which were quite good for me and quite appealing to me. The goal is not to measure which language is better, just to share my personal experience. So let's start the story how I became a Go boy. My name is Fero Kaduk. I'm working at Outreach. You can tweet me on Twitter. I'm blogging time to time on my side. Most of my life I spent programming in C# and just started to write in Go. So hello and defer goodbye. In my journey sharing session, I will talk about language gotchas, runtime gotchas, toolset, and summary. So let's start with language. I started to look at Go during my vacation, and I basically went, to Effective Go website, and there you can basically see and read about Go and directly try some playgrounds and try. And it was really quite simple, but I still was thinking what is this language about. So I then read, GOlang spec. And honestly, it took me just not so long time. And guys, honestly, I was working for C# or in C# in .NET. I never read, C# spec. It was crazy long. I don't know how about you, but it was for me too long. Probably only John Skeet read it. So I went through this and read this GOlang specification. It looked quite okay. So. But the problem is that I wanted to understand, core idioms of the language, so that when I write the code, it will not look strange to others, especially to veterans in Go, which we have in our company. So, and when I was writing, I was all the time just comparing, C# and .NET, and it's, it's object-oriented programming style to Go. And I've tried basically to apply it all the time. And honestly, this was a mistake. This was wrong. So I can say that, C# is basically, the object-oriented programming language. But GOlang, I had the feeling sometimes it's yes, sometimes it's not. It has many commonalities, but also many buts. Go is statically typed language. It's compile safe. It's memory managed programming language. So it's very similar on the surface to C#, but very different in the nature. Go, for example, doesn't have root class. It doesn't have type, some hierarchy. There is no root class like we have in C#. But it has structs. It has interfaces. It feels quite lightweight, and this was, quite appealing to me. So let's look at first construct. So first, when I sit down and try to work on my own, we start to create the object. In C# we know that we are creating a new instance of the object through constructors, and we pass there some parameters or some params. In GOlang, it is a little bit different. GOlang supports zero-value objects. And zero-value objects are specific. These are basically, really zero-value objects. I'll show you on the example. If you have a little bit more complex construct, or if you need to check some invariants when you are creating the new instances, or you want to build some builders and so on. There are constructors like functions. There is the naming convention that this function starts with new and then type name. Then you pass there some arguments and then return this type. And basically, you create probably inside this function the new instance. Comparing to C#, it also supports the params. They are calling the variadic arguments. So let's look at one example. I'm defining struct person and with some fields. And here is an example of the usage. So as I was saying, here is zero value object creation. So basically, when I'm defining a variable A of type person, by default, compiler creates the code which directly instantiate zero value object. What does it mean? It means that name will be just empty string, age will be 0, and person, like the children, will basically be empty slice. And then on line 32, I'm just going to manipulate this new instance. I'm going to set the name. If I would do this in C#, I would get directly null reference exception. But this is possible here in GOlang, and it is pretty common. Another type of creating new instances is basically just defining person and directly setting up the properties. And the third option is defining this constructor-like function, which is based on the naming convention. It starts with new, and I'm creating basically new object. In this method, usually these methods are more complex. We are checking their invariant and their conditions for name, for and so on. I was trying to find out and understand why it is so. The reason is mostly the simplicity of the language, and RockPipe, which is basically author of the language, he invented this feature and basically says, make the zero value just useful. So this is one of interesting things which I found in Go. So okay, I was able to create the new objects, but now I want basically to author new structs. In C# we know we have reference types or value types. As I was saying, we have the type hierarchy where a root class is system.object, and it has some basic methods. In GOlang, we have only structs and interfaces. And structs, they hold the data, and we are able to define the methods which are working with these structs, or which basically receives these structs and are coupled to the structs. We are able to define how we plan to work with these structs, and this is expressed as data semantic. And we are able to define there by value or by reference, which means when I will be when I will be calling some methods on the struct, and I define data semantic, that every call will be on a copy of the objects, or it will be by ref, which will be the pointer, and which means and this is really basically core idiom of the Go language and very powerful. But when I was starting to look at it, I didn't understand it very much, and it took me a while, to start to feel this core idiom. And then we have interfaces, and this interface is just set of the method signatures, and basically that's it. As I've told, we don't have there any base class. And when I was trying to understand why it is so, I found on Go blog post, GoLang tries to address some fragile base class problem. You can find it on Wikipedia. This is quite a known issue of all languages. And so in Go, we are favoring the composition over the inheritance. And Go adds there a little bit sugar. And I was, this was basically my first thing. It looked to me very strange. And I also blogged about it on my blog site. And let's look at one example. So here on the first lines, I'm defining a struct called square, and I'm defining a method for this square struct to calculate, some area. And then I'm defining, damaged square. And this damaged square is basically, just embedding the square, so composition over the inheritance. So I'm basically just, going to embed the square, and I'm defining there some additional field. And I'm also overriding or defining or overriding this case, the area method. This embedding means that all the methods which were on the square are visible on damaged square. This is this specific thing for Go, which adds to composition over the inheritance. And now let's look at the usage. So I'm defining a new instance of damaged square, and you already saw it how to create the new instance. And here I'm printing the area and the area. So on line 32, this is damaged area square, and on line 30, I'm also able to look to the square itself. Or what I can do, I can define the interface. I call it shape. And as I told, this is a set of the method signatures. And on line 34, I'm saying that the instance D meets or fulfill all the method sets which are defined on the shape interface. And that's it. And as you can see, I don't need to define on any place that square implements this interface or the damaged square implements this interface. But so basically, if the instance meets this interface, or some instance type meets this interface, I can cast, or I can then just assign. And I was trying to find out a little bit more sense of it, and to be honest, there is great talk by Dave Cheney. He's also working for Google about solid Go design. And honestly, this is open-close principle directly in the language. So this is super interesting, honestly, for me. So that we can see square is closed for modification, but open for extensions, which is, which I show it here on damaged square. So this is quite interesting for me, or was interesting for me. So, okay, I'm able to create the new instances and define new types. Now, okay, I don't want to have everything public and so on, right? So in C# we are able to define what are the public members, protected, private, internal, and so on and so forth. In Go supports public and private. That's it. And this is based on the capitalization of the first letter in the type name. So as you can see, type person with capital P is public, and type person with small p is private. But there is also, the internal, and these are the publics in the internal folder. Go and Go compiler just define some folder structure if you follow it. So there is some standard, which is cool. Then you can get also the internals. There was one gotcha for me, and this was that public methods can return, some private objects. And the C# guys should repeat it and read it several times. For me, it was very interesting. How can the public method return some private objects in C#? I would get some compiler error. So let's look at some small example. For example, here in the log package, I have a with method. And with method, returns me, a logger instance, and this logger instance is of type, the logger, and it is with small l, which means it's private. But this private can have some public methods, and it has some error. So, for example, I'm able to get, some instance of this object and call the public methods. In C#, I wouldn't be able to do this. And what more, I can define interface with, for example, in this sample or demo with one method, and I can just assign the newly created logger some private instance to this public interface, and I can start to use. Then I can start to work with it. This was for me quite interesting and different than in C#. So okay, I was able now to define also the visibilities and so on. And now I would like to bundle it somehow, right? So in C#, as you know, we have a project. They have CSproj folders. Everything is compiled to the assembly. Then assembly, we can basically reference the assemblies, to NuGet or NuGet called sometimes. And these assemblies or these packages are versioned and can be for platforms and so on. In Go, we have a very similar concept. So again, this is feature which is very similar on surface, but different in detail. So GOlang has modules and packages. Modules are similar to NuGet packages. They have also versions and so on. But modules contains folders. We call them in GOlang, like packages, and they're basically, namespaces in .NET. That's it. And when I'm using the module and referencing some package, which means some namespace, I'm referencing it by using the source code directly. So source code is compiled into my application directly. And I remember the days in C# when you have this issue that you have some project or you have some service and you are using some NuGet package and there is a bug or you want basically to debug it. If you don't have some PDB files, it is very hard. So then you need to use some JetBrains, the compiler and blah blah. Here it is super simple. I was really happy how it is done. And here is some example. So we have a project, we have there one file, Go mode, and here we are defining what packages we want, we require. It's some versions or tags. And here is then when the project is using it, I have all the libraries nearby me, so I can look at them and debug them and so on and go inside. So okay, I was able to do all these things, and now sometimes when I'm calling some service or something, or I do something, we have there some errors. In C#, the errors usually we throw exception. We throw new exception or retro exception, and then we have try-catch finally blocks, right? In Go, it is different. Go treats the errors as normal return value. And it's called responsibility to check and handle it. To check it and handle it. This was a little bit different, or this was a little bit strange to me, but this is how it is. And there is also a construct for panicking. So the panic, then we have defer and recover, which is similar to try, catch, and finally, but it is really rarely used. It should be used really with caution and not so often. It has its reasons why it's there, but usually we return the errors and check for errors. So okay, I was quite happy with this, but many times we write the asynchronous code. Okay, these days most of the code works just asynchronously. In C#, we have the async await constructs, and basically it is and we have it because we are instructing the compiler to generate the heavy state machinery behind it. and we have their synchronization contexts and async locals. And if we don't want to switch between sync and async, and we want to have purely async part, then we're flooding our code from bottom up with task of T. In Go, we have Go routines. And to be honest, this is for me the most attractive feature I found in Go. And Go routines are very similar to tasks. Difference is that they are built from the beginning in the language. So there is basically natural support in the language, or in method signatures. So they feed really naturally into this, and we don't have there any some async local state or thread local state. There is thread local state, but it's quite hidden, and there are some places where Google code, like STD libraries, are using it, but not you as a developer will be using it. So, but instead of this, we have a context object or struct, and we are able to store there the data which we want to propagate to asynchronous flows or Go routines. And we can put there some allocation data or some cancellation tokens and so on and so forth. So, okay, I'm able to write the asynchronous code with Go routines, but there is something more. Quite often, we need to basically give the data to Go routines. And when you have multiple tasks which are accessing same data, you need to have there some synchronization primitives. In Go, this is solved by really another very interesting and second quite attractive feature which come hand in hand with the Go routines, and these are the channels. Rob Pike, the author of GOlang, says don't communicate by sharing memory because of locking and so on. Share the memory by communicating. So how? By channels. So let's look at the example. So on line 13, at the very top, I'm defining context with the timeout, which this is basically some kind of saying, the cancellation token with timeout. And then I'm creating on line 15 a channel, and there are various types of the channel. Here, I'm creating a channel C, and on line 22, I am starting a new Go routine. For example, this is the Go routine which will go to some database, load the data, and push this data to the channel C. And then another Go routine, this is some next task. This is basically receiving this data. I'm simulating GOlang sleeping, but this second Go routine is loading this or is receiving this data from that previous channel and processing them. Very simple use case, very clean use case, and usage in general of these Go routines and channel. They go really hand in hand. This is really super feature in Go, which I like very much. And again, Rob Pike, channels to orchestrate and mutexes to serialize. And this wouldn't be possible without Go scheduler. We don't have a time to go into the details into the details of the Go scheduler, but this is basically very similar, or this is basically some machinery behind this. So we don't need to create some async state machines and so on and so forth. So these were the channels and communication. Now we're going to runtime. So language. These were like most nice feature for me in the language. Now let's go to the runtime. Kind of often I was wondering, okay, where the memory is allocated. I'm defining structs and defining data semantic, by value, by ref, and so on. And I was trying to find out where the data are allocated. And A Go compiler analyze your code and decide where to allocate. So you are not in charge of it. The Go compiler will decide. And you can see this is quite interesting because as we move the responsibility for collecting the garbage to garbage collector, here in Go we are going and asking Go compiler to ask us to basically to ask it, hey, solve for us where to store the data. On this example, I'm on line 12. I'm creating a new small struct object and passing back the reference. In C#, it would go to heap. We have a tool, Go tool, compile -m. This is how we are asking the Go compiler for the escape analysis, where it will be allocated. And we can see that on line 13, a small struct is going to the heap. Fine. Now, if I will remove this Go, no inline line, Go compiler will try, to inline it, and it will find out, hey, this instance is used only in the method, so I will able to basically just allocate it on the stack, not on the heap. And why it is important? Because every allocation on the heap has to be cleaned, and has to be cleaned means some CPU cycles, and it means it has impact on the performance. Sometimes not so much, sometimes can be. And this is, we are coming to the next, this is, garbage collection. In .NET, we have garbage collector, and we are basically allocating stuff on the heap or on the stack. In Go, it's same. Again, it's very similar on surface, but very different in the nature. So let's look at .NET first. In .NET, we have small object heap and large object heap, and we have there several, sorry, here is a mistake, Gen 0, Gen 1, and Gen 2, generations. We have there several generations of garbage collection. We have there, and runtime has to track also cart table, and we have the different modes with the workstation, server, and so on. In Go, we have single generation GC. And we also split the data to the small object heap and large object heap. A large object heap is over 32 kilobytes. And for small object heap, it's using segmented memory. And the algorithm behind garbage collector, which is powering this garbage collection, is based on tricolor algorithm. And it's quite simple. There are plenty of resources on YouTube where you can look at more details, and it is pretty efficient. So this was runtime part. Now we are going to the last tool set part. As I already told about it, the SQL analyzer. This is pretty interesting tool which I'm using. I'm using also the object dump. This is basically very similar to EL DSM, where we can look at the IL code. Here I'm looking at the assembler code, and you are able to basically navigate through this. It is not so crazy. We have also GOlang for linting. So basically we adhere to some coding standards, and also Go formatting. No more wars, tabs, spaces, and so on. There is some standard formatting, and we try to follow it. And really, it simplifies stuff, the coding. But there is one more thing which I'm using pretty often, and this is tracing and profiling. We use it quite often in Microsoft when we wanted to build performance services, and in .NET we were using Perfew. To capture, some ETW events. On Linux also there is something similar. And we use also various bunch of profilers, like ANS profilers or Azure profiler, which was really pretty awesome. In Go, Go runtime also provides this information. And there is a package, pprof package from Google, which gives you the possibility to expose this internal information to you. And you can also do tracing through this. And it's really simple. I'm going to show you the tracing. So first the tracing. The tracing, you can ask, the Go service or Go application just to trace some execution, and you can get the full trace, or go to the analysis or blocking profiles, and so on, and so on. And you basically get really big insight what's going on under the hood and where could be the problems. Here is, for example, I took some trace. Here you can see the process where I'm running on 2 cores. You can see here proc 1 and proc 0 and 1. Here are all of the Go routines. Here is, for example, some system calls or network calls and garbage collector, and plus some other stuff. Here I see when the garbage collector ran. Here I see that network finished. So I got stuff from the network, and now another Go routine is going to continue and use this data. This is really detailed inside what's going on. This is pretty super awesome from my perspective. And then we have profiling. Profiling is sampled. This is a traditional flame graph, so I can see what's going on in basically the system. When I have some blocking calls or on CPU calls and so on. I can have the same view, just or same data, just different view. I can have also graph and seeing how it is called and where most of the time is spent. And I can also profile the memory. So I see how much object or how many objects are created, how much of space they are using, and so on. Really detailed information. With these tools, you are able to basically see everything what's going inside. Guys, that's all what I wanted to share with you. So let's summarize. Few concepts which are in Go are very similar on surface, but really different in the nature. And me as a guy coming from .NET, I can say that like half of the things are similar and half of the things are different. And generics, I'm using generics, they're coming, they are basically in beta now, and they are coming at the end of the year. We'll be able to use it. Just out of the curiosity, I took GitHub statistics, how the language is popular. And we can say this is GitHub based on the pull requests, and Go is pretty popular and going up. Resources. I'm using most of the time GopherCons or Strange Loop conferences. We have trainings from Ardan Labs. This is a company in the US. We have also some Ardan Labsers, guys from Ardan Labs in outreach. I'm following Go weekly. And honestly, I'm also learning from the colleagues. So that's all. Thank you very much for watching.